Good morning to all three of you, um, and to everyone else who watches this on video. Glad to have you on board. So I'm going to just quickly review what we went through yesterday, and then I'd like to spend the majority of the time on the things that I did not have time for yesterday. So up until now, we've been doing derivatives with the limit definition, the long way. Today, or yesterday, for the very first time, we learned some rules that allow us to take a short approach to that. So you can see them listed here: the constant rule, the power rule, the constant multiple rule, the sum and difference rules, sine and cosine, and e to the x. How do you take derivatives of that? So and this is what I didn't have the link right yesterday, but don't forget I've got this independent website that shows all this stuff and gives a description and might be helpful for you to look back. And if you need a point of reference, please make use of that. Okay. So the first rule was called the constant rule. And the constant rule says, hey, if you take the derivative of a constant, it's always zero. Okay, and we showed why that was true. The second one is called the power rule because it deals with x to different powers. And you can see when we take the derivative of x to a power, what? You take that power n, bring it out in front and multiply the entire expression by that, leave x and reduce the power by 1. Okay? The constant multiple rule says if there's a constant out in front, you can basically just ignore the constant and go ahead and do the derivative of the rest of the function. So you see here we have a constant times f of x. Just leave that constant out there and take the derivative of the rest of the thing. We also just kind of announced this. The derivative of the sine is the cosine, and the derivative of the cosine is minus the sine. Memory work for you. We're going to learn other trig functions later, but right now that's as far as we're going to go. And then the derivative of the exponential function e to the x is itself e to the x. Okay. So where we were talking about rates of change. And very welcome, Jen. It's very important that you should get this in your notes. Okay, when you want to take when you're asked to find an average rate of change, all you're really asked for is finding the slope. So that's nothing new at all. But that terminology is extremely important. Average rate of change. When you're asked to find an instantaneous rate of change, that's where we're going to apply the derivative, which is what we've been working on that. But you need to differentiate between those, and some of the problems they're going to give you are a combination of both of those. We can skip ahead here to, I think, this is the problem we were on, I believe, when the class period ended. So this is from the assignment. It's number 94. They give you a function, t squared minus 7, and then they give you an interval that so from between 3 seconds and 3.1 seconds. And they ask you to find the average rate of change And they ask you to find the instantaneous rate of change at the endpoints. All right, so for average rate of change, you notice we don't have the complete ordered pairs here. So the first thing I'd like to note is we're doing this, grab my pen here. So this is an interval up here. And we've got to figure out the ordered pairs. So all I did was take the 3, so this is for t equals 3 to t equals 3.1. So plug in a t of 3. 3 squared is 9, 9 minus 7 is 2. And so you gotta do a little calculating to find your y coordinates. And then likewise, at t equals 3.1, we had to plug in 3.1, get the answer, subtract, you get 2.61. So now we've got our two ordered pairs. The first one, they're both endpoints. Now we can find the average rate of change. y2, 2.61, minus y1, 2 over x2, 3.1 over x1, 3. You get 0.61 over 0.1, which is 6.1. That is your average rate of change. So it's strictly a slope, but we had to do a little bit of work to get the points. Okay, so now the second part of the question, the instantaneous rate of change. I should write that in here. So we've got the instantaneous rate of change. Now we need a derivative. So what's the derivative of the function f of t? Power rule, 2 times t, reduce the power by 1, minus 7, the derivative of a constant is 0. So here's your derivative. Okay, now what's the derivative when you're at the first point, 3? What's f prime at 3? 2 times 3, 6. And secondly, what's f prime at 3.1? 2 times 3.1 is 6.2. So the first answer is, what's the average rate of change? That's this 6.1 over here on the right. And the instantaneous rates of change are at the two endpoints, 6 and 6.2. Now, you may notice that the average of 6 and 6.2 is 6.1, which was the average rate of change. But don't expect that to always work. Okay, that will not always work where it's the average of the two, because a function between two endpoints can do some crazy things. But nevertheless, there's the first average rate of change problem. Then, does anybody have any question on that? Welcome, Rachel. And anybody else that came in? I don't think so. So let's take a look at this other problem that I prepared. Again, it's the same kind of thing. I give you a function, f of x equals x squared. And part A, find the average rate of change over the interval from 1 to 3. You know, I should have really, let me make that a closed interval. So I'm going to change those brackets. Because then it includes the endpoints. It's a little bit clearer. So find the average rate of change over the interval from 1 to 3. All right, so I need some ordered pairs. This 1, 3 is not an ordered pair. That's an interval. So the first ordered pair would be what? 1, comma, and 1 squared is 1. And the second ordered pair, when you plug in a 3, 3 squared is 9. So there's the completed ordered pairs. Now, how do we find the average rate of change? Well, you know this by now, we got to do a slope. So let me move this over a little bit. So we need to take y2, 9, minus y1, 1, over x2, 3, minus x1, 1. We get 8 on top, we get 2 on the bottom. There's the average rate of change, 4. Now, the second part says find the exact rate of change at the endpoints. Well, we need to find f prime of x. So here we have to we need to use our derivative. What's the derivative of x squared? Power rule, 2 times x to the first. Okay. Now, what's the derivative at the first endpoint? 1. This is the, and again, what you plug in here, as you can see with the x there, is you plug in the x coordinate. What's f prime at 1? 2 times 1 is 2. What's the derivative at the second endpoint when x is 3? 6. So, average rate of change, slope, turns out to be 4. Exact rate of change at the endpoints, f prime at 1, 2, f prime at 3, 6. Okay. Anybody have a question on that? Let's take a look. Let's take a look at number 96 in the book. Number 96, again, is one of these problems where you have to find average and exact rate of change. So the function is up there on the top. It is f of x equals sine of x. The interval is from 0 to pi over 6. So we need some ordered pairs. So we plug in a 0 for x. What's the sine of 0? 0. So there's our first ordered pair. And the second x coordinate is pi over 6. The sine of pi over 6 is exactly 1/2. So there's our second ordered pair. Average rate of change, take those two endpoints and do a slope. y2, 1/2, minus y1, 0, equals x2, divided by x2, pi over 6, minus x1, which is 0. Okay, on top you get 1/2, on the bottom you get pi over 6. How do you divide fractions? You invert and multiply, which I did down here. And you see we get 3 over pi. So, and that's it. That's our average rate of change for the function over that interval. Now let's find the exact rate of change at the endpoints. So the first thing we need to do is find the derivative. We learned yesterday that the derivative of the sine is the cosine. Okay, and then what's the derivative at the first endpoint? 0. What's the cosine of 0? 1. So there's our first answer. And then the second one, we take the derivative of at the second endpoint, pi over 6. The question is, what's the cosine of pi over 6? Well, it's square root of 3 over 2. And I just put approximately equal to 0.866, but actually this answer is the square root of 3 over 2 is correct. And that's, I'm guessing, it's the square root of 3 over 2 that you'll probably find when you look up the answers. Questions? So, one more time, when you're asked for average rate of change, you've got the x coordinates for the interval, so you got to find the complete ordered pairs. That's step 1. Step 2, put those into a slope formula and simply do the calculation, then you've got your average rate of change. When you want to find the exact rate of change, you have to take a derivative. And we've just recently learned some nice shortcut rules for that. Take the derivative, and then that's your general derivative. Now take the derivative at each endpoint. And you got your problem complete. Okay, now something else I need to talk about, and another problem type we're going to do is in the book they'll ask you to find the velocity. So the first thing I got to do is make a note to you that when you're a lot of times in the book you're given formulas that look like this. S of t equals negative 16 t squared plus something t, plus something like that. What that is that's a formula that is for that's the formula for the height of a falling object. So at t seconds, how tall is this object that was dropped from 50 feet or whatever? And you'll get an equation like this. Okay, so that's basically a distance or height formula. When you take the derivative, and let's do this derivative, 2 times negative 16, reduce the power by 1. This one, 1 times 2 is 2, reduce the power by 1. So there's our derivative, and this is the new part. That's how you find the velocity. Actually, you can go further than that, but that's as far as we're going to go. I mean, you can also do acceleration, but we're going to just deal with this. So this S of t is just a physics way of saying displacement or distance. And whenever you want to go from a distance formula to a formula for instantaneous velocity, that's perfect time for the derivative. Okay, so let's take a problem now. And I'm going to look to the book for this. I thought, yeah, there we go. Number 99. Okay, I can't make this any bigger, but what I can do, let me copy that. Okay. So here's our problem we'd like to work on. And I want to, it'll apply to what we're doing here. You see, here's that S of t thing. See that? S of t equals negative 16. By the way, what's this negative 16? Why is it negative? It's an expression for gravity. And it's always negative because gravity always pulls downward. So when you're doing feet per second squared, it's always, I mean, that's just an expression of gravity. So you're going to see that negative 16 there. Okay, so let's do this problem. Silver dollar. Oh yeah. Well, they didn't tell you this, but when you finish this equation, here's what it looks like. I forgot, what is the V2? Yeah, I can't remember what V0 is, but the distance you dropped it from was 1362. That becomes that thing, the height you dropped it at. Okay, so it says determine the position and velocity functions for the coin. Okay, well, here is the position or height. Okay, the velocity would be the derivative of that. Okay, the derivative of this is power rule, negative 32t. That's it. Because the derivative of a constant is 0. Okay, so we've done part A. Part B, determine the average velocity on the interval from 1 to 2. Okay, so here, this is just like the problems we just did. So 1, what's the height you get when t is 1? 1 squared is 1. 1 times negative 16 is negative 16. And negative 16 added to 1362 is 1346, right? 1362 minus 16. Okay, and the other point you want to do, as it says right up there in the problem, is 2. So what height will the object be at 2 seconds? So 2 squared is 4. That's negative 64. And that brings us down to what? 1298. Okay, so there's our 2 points. So now to find average velocity, you know this, we need to find the slope. So average velocity, y2 minus y1 over x2 minus x1. So what do we get? 1298 minus 1346. So it's what, 48? Negative 48. And so the average velocity is negative 48. And this is, are we talking? Yeah, this is feet per second. So in other words, between the second 1 and the second 2, the average speed was falling at a rate of 48 feet per second. So there again, we have average rate of change where you're simply finding slope. Okay. Now, I'm going to move this up a little bit so we can see better. Part C. Find the time required for the coin to reach the ground. Okay. Now, this is strictly an algebra problem. All right? Because what will happen when the coin reaches the ground? The height will be 0, right? So we're going to have 0 equals negative 16 t squared plus 1362. All right? Now, how do I solve that? Well, this is an algebra problem. I mean, in this case, we actually don't need the quadratic, because we could use the quadratic, but we could just subtract 1362 from both sides. And then we could divide both sides by negative 16. And we'd get t squared equals, and 1362 divided by 16 is 85.125. And then take the square root. And find the square root symbol. 9.22. So in other words, we just found that it takes 9 seconds for this coin to hit the ground. Okay, and that makes sense. I mean, after all, we dropped it from a height of 1,362 feet. So, okay, So we've done part C. It'll take 9.22 seconds. Part D. I'm sorry, we haven't done C yet. I see, I mislabeled that. That's part D. So let me go back. No, I did these out of order, but that's fine. Okay, let's do part C now. What's the instantaneous velocity when t equals 1 and t equals 2? Okay, I'm going to have to, running out of space here. Okay, so for part C, what do I need to find instantaneous velocity? I need to find the derivative. What is s prime of t? So you got to look up here now at the function itself, right? What's the derivative? Negative 32t. And the constant, derivative of a constant is nothing. So now what's s prime at 1 second? Negative 32 feet per second. What's the derivative at 2 seconds, which they also asked us? Negative 64 feet per second. Right? You're just taking it times negative 32. Okay. And I'm running out of space, so I'll do it right here. What's the velocity of the object when it hits the ground, which is what he asks at impact? Well, that would be s prime at, remember, here it is, 9.22. And all we got to do is multiply it by 32. 32 negative times 9.22. And we get negative 295 feet. So 9 seconds after this thing is dropped, it has, of course, picked up speed quite a bit. Okay, so this is just kind of a sample of working with dropping objects, which is usually, I mean, that, you'll see that's, I think that's in your assignment. And if not, it's going to be coming. So there's a sample of that. So let me take a few minutes. I probably went to, okay, if we have problems like the velocity ones, yeah, you'll be allowed to use it. Well, I mean, I could have done those by hand, a multiply, but because we're online, I did them with a calculator. So will we need a calculator? You should be able to do that without a calculator. So I just did it to keep things rolling and for the video. Okay. Does anybody else have a question on a problem like number 99? That's that one we were just looking at. All right. Well, let's look at the assignment. We did that yesterday, I think, briefly. It's that 3.2 assignment there. One to 53 odd, 57, 87 to 92, and 93 to 105 the odds. Any questions? So that then is the assignment for tomorrow, for Wednesday. Questions? All right, we'll sign off then. Thank you. I appreciate your attendance, and I'll see you tomorrow.